Imagine having a powerful distributed database right on your laptop. That's exactly what we are about to create. Apache Cassandra is a distributed NoSQL database designed to handle massive amounts of data across many servers. It's a powerhouse database system, highly available, horizontally scalable, and incredibly fault tolerant. But why set up a multi-node Cassandra cluster using Docker? Let's break it down. First, it's like having a mini data center on your local machine. You can simulate close to real-world scenarios and debug distributed database issues without needing multiple physical machines. Need to evaluate your app's performance with increased data load? Adding nodes lets you simulate scaled environments and effectively stress test your application in a control setting. You can experiment with different replication strategies and consistency levels. Think of it as a miniature lab for experimenting with data distribution. Docker ensures everyone on your team has the same setup, so no more it works on my machine excuses. Need a fresh start? Just tear down and spin up a new cluster for a clean slate. Unlike running multiple virtual machines, Docker keeps things light. Your laptop won't sound like it's preparing for a takeoff. So what exactly are we setting up? Picture 3 Cassandra nodes, each in its own container forming a tiny cluster. We'll create a custom network for them to communicate, map their ports so you can talk to each one individually, and configure them with environment variables to play nicely together. By the end of this setup, you'll have a fully functional Cassandra cluster running locally. Now, let's dive in. First, let's create a custom Docker network for our Cassandra nodes to communicate. This command creates a new Docker network named CassandraNet. Next, let's start our first Cassandra node by running the following command. Let's understand what this command does. The -d flag runs the container in detached mode. Then we specify the container name, set the host name to Cassandra1, connects the container to our custom network we created earlier. Then we map the Cassandra port 9042 to 9042 in our host. Then we use the -e flags to set the environment variables for our Cassandra configuration. Here we first set our cluster name and the data center and the rack this Cassandra node belongs to. Then we specify something called the Cassandra endpoint snitch. This tells Cassandra how to locate the nodes and route the request. It plays a key role in request routing and the distribution of the replicas. Here we use the gossiping property file snitch, which is also recommended for production. There are many other snitch protocols, such as Simple Snitch, Property File Snitch, EC2 Snitch, Google Cloud Snitch, and so on. I have a link in the description if you want to read more about it. Lastly, we set the number of virtual nodes this node uses. Virtual nodes distribute data across the cluster by assigning each piece of data to a token on the ring. The more tokens, the finer the granularity of the data distribution. And finally, we specify the latest Cassandra Docker image for our container. Let's run this command to create our first node. Next, let's create the second node. Notice we have added a new environment variable called Cassandra Seeds. This tells our second node how to find the first node to map the topology. The Cassandra1 is the host name of the first container we created just now. And we map the port 9042 to 9043 in our host. And finally, we add our third node. And respectively, we map the port 9042 to 9044 in our host machine. And just like that, we have our 3-node Cassandra cluster up and running. To manage and monitor our Cassandra cluster, we use a tool called nodetool. It's a command line utility that provides various administrative functions. With nodetool, you can check the status of the cluster, view information about the nodes, perform repairs and cleanups, and much more. Let's start by checking the status of our cluster by running this command. This command connects to the Cassandra1 container and runs the nodetool status. It shows the state of each node in the cluster, including whether it's up and running and how much data it's handling. Here you can see the status of each node. UN means the node is up and normal. This confirms that our cluster is running smoothly. You can also get detailed information about a specific node by running the following command. Here we see Cassandra1 nodes load, token count, and much more. These details will help you monitor the health and the performance of your nodes. Now let's simplify our setup by creating a reusable docker-compose file. This will make managing our multi-node Cassandra cluster even easier. First, let's create a file named docker-compose.yml. This file will define our entire Cassandra cluster setup in a single place. Let's break down what's going on here. We start by defining our services. Each service represents a Cassandra node. For each of these services, we specify the image, container name, host, network, port, and the environment variables. We can use the YAML anchor to specify all our environment variables in one place and reuse it in other services as such. Also notice we use the depends on keyword to tell when the specified container should start up. In the case of Cassandra 2, it will start up after Cassandra 1 service starts up. Likewise, the Cassandra 3 service will start up after Cassandra 2 starts up. Finally, we define our custom network using the bridge driver. To start our cluster, simply run the following command from the directory where your docker-compose file is located. This command will spin up all 3 Cassandra nodes and connect them using the custom network we defined in the file. Just like before, we can use the node tool to check the status of the cluster. For example, to check the status from Cassandra 1, let's run the following command. This will show the status of each node in the cluster, confirming that everything is working as expected. To shut down the cluster, simply run docker-compose down. And there you have it, a fully functional multi-node Cassandra cluster running locally using docker-compose. If you try this out, I'd love to hear your results in the comments below. Before we wrap up, I'd like to give a special shout out to this insightful article which served as a foundation for this video. You can find the link for this article in the description below. Thanks for watching, and I'll see you in the next video.